Jumping into OWASP Top 10, number 2, broken authentication. So for an overview, to best understand broken authentication, it's good to understand exactly what authentication is. So to define it, authentication is proving a user is who they say they are. What does that mean? Well, the most common example today is just the username and password. If you go somewhere in person, like the DMV, they might ask for something like a driver's license. That's also a form of authentication because they look on there and they see your picture and your name, and they look up at you and they can see that your face matches the picture, and so the name and description on the driver's license should be who you are. Authentication is considered broken in an app when attackers are able to run any of these types of attacks. There's brute forcing, credential stuffing, dictionary attack, top 10,000 password list. To define these real quick, brute forcing is just going through in serial, just running every single possibility, starting off with 1 character long passwords, 2 character long, and it'll go through the full alphabet and all the numbers, and you know, it'll try every single different type of combination, and it takes a lot of time to do, but it is possible. Dictionary attack is similar, but it's just, it takes a full dictionary of words as input. So it'll just use the most common words used in passwords, and it can be a lot quicker than doing a brute force attack, but its success rate kind of depends on just how complex user passwords are. For credential stuffing, that is taking previously breached databases where there are millions and millions of user passwords, or maybe billions of user passwords that have already been used, and throwing all of those passwords into a list to run basically a brute force attack with them. But the difference between that and a brute force attack is, instead of running through every single possibility in our language, you're only running through every known breached password that there is. And it turns out users around the world reuse a lot of passwords. So credential stuffing is one of the top ways that accounts get breached these days. And that's why multi-factor authentication is so important, and we'll talk about that later. There's also top 10,000 password list. That's similar to credential stuffing, but there's just a list out there called top 10,000 passwords, and these are just the top 10,000 most common passwords out of those billions of passwords that have been compromised. So it's pretty dangerous. You don't want to have your users using common passwords like you know, the name of their son or daughter, or just the birth date. That's really bad. If your forgot my password process is broken, or you have poorly written logic in your app, hackers might be able to bypass that and just reset a user's password and gain access to their account. So that's pretty bad when that happens. Recovery questions may be easily guessable or provide too few answers to choose from. Believe it or not, this does happen, but here's an example here. So how long would it take an attacker to gain access, unauthorized access to somebody's account if this is the kind of security question you set up? What is your favorite car? You only have 3 options. So hopefully there's a bunch of security questions here in this example, because if an attacker tries to break into your account and there's only a single question with 3 answers, it's going to be pretty easy for them to break in. Now, talking about the impact of broken authentication, there's so many possibilities, from impersonation to money laundering, social security fraud, unemployment fraud, ID theft, classified information leak. And I'm going to give you an example from the real world here too, just so you know the gravity of this kind of vulnerability. In 2017, an online database was discovered by a security research firm, containing over 560 million user passwords. The identity of the person that owned that data is still unknown. I believe this was actually reported without proper disclosure because all of those 560 million passwords in this database were already from previous breaches. So it was the work of some unknown person, hacker probably, wants to use it for nefarious purposes, who has been gathering these password databases from previous security breaches on the dark web, for example. And they've been just amassing them into this big database of passwords. 560 million is 500 million, and that's not even a small chunk of the total passwords that have been leaked out there. There are billions and billions. But this is still a pretty high number, and surprising that it was just accessible publicly online and left unsecured. So it was discovered by a Cromtech Security Research Center, which is a cybersecurity firm, while scanning the internet for vulnerable MongoDB databases. From this report, according to Diachenko, the device is running an insecure version of the open source database program MongoDB, early versions of which are notoriously easy to misconfigure. The default settings in these early versions of the program allow anyone with know-how to remotely browse database contents. So in other words, the answer is just in their documentation, and it's insecure by default. So talking about prevention of broken authentication, the most prevalent way is to use a CAPTCHA. And if you don't know exactly what that stands for, it does mean something, but it stands for the completely automated public Turing test to tell computers and humans apart. I just learned this a few months ago when I was researching web vulnerabilities, and I never knew that it actually stood for something. Thought that was pretty cool. Here's a interesting example of an old CAPTCHA from, the 90s and 2000s kind of era. This one's weird. It actually says Gimpy or Clive. I don't know what that is, but these were really, really broken forms of CAPTCHA, because it's obviously not that hard for a computer with screen recognition to be able to determine that that says Gimpy or Clive. If a human can look at it and determine that, then a machine is probably able to eventually, with enough training or enough programming, to look at that and figure that out as well. And it turns out that there were really nefarious services that were available on the dark web that actually allowed malicious attackers to sort of set up an automated way of solving these CAPTCHAs too. So if it was too difficult for a computer or script or program to solve, for an attacker to break authentication on the website, then they could set up one of these dark web services. They could pay, a cent for 100,000 queries or whatever it is. It's not that expensive, but all they do is have their script send these CAPTCHAs in real time as they come up in their software, in their automated script, to send it over to that dark web service. And then that dark web service inserts that same CAPTCHA into another website where an unknowing user just goes through within a few seconds and is presented with that CAPTCHA. They solve it, and that result to the CAPTCHA gets passed on to the hacker. So in other words, it's just a really weird system, but they set up infrastructure to automate solving this, which means that it's completely broken now and shouldn't be used. There's a new form of CAPTCHA. This one's called reCAPTCHA. It just means kind of a new generation of CAPTCHA, but this one's newer, smarter, has a lot more automated detection capabilities than the old broken style of CAPTCHA. So if you use a CAPTCHA at all on your site to prevent scripts and automated attacks, use the reCAPTCHA. haveibeenpwned.com is a website where you can go and actually enter your email address, or anybody's email address really if you're interested, and you can see what previous data breaches that email address has been associated with. This is really useful if you want to help harden yourself against credential stuffing attacks, because those previous breaches are potentially have exposed your password that you might use for multiple accounts. And those hackers have a hold of those databases, like you saw in the 560 million password database leak. It's pretty easy for hackers to get a hold of those. And I've been victim to this myself in a Twitter account breach years and years ago. And I didn't know the reason why my Twitter account was breached, nor did I care because I didn't use it. But the point was, later on, I found out that it was because of a breach from several years prior. This can also integrate with your application. It has an API. Up at the top of this website, you can click that to go to their API documentation, get an API key, and you can actually automate checking your user accounts for your web app against this database to see if they're at risk of a breach, or if their information was previously leaked in a breach. You might want to let them know. But yeah, that's available as well, and I believe it's free. Talking about prevention of broken authentication. As I mentioned earlier, you want to implement multi-factor authentication where possible. And that's just basically requiring anything besides just a username and password. Usually the way that that's done is through something like Google Authenticator, some kind of third-party service like that that your users can easily just download on their phone and use that for authentication, where it gives them a code when every time they go and log in. Another possibility is SMS two-factor authentication, where it sends them a number code through text. Those are all forms of multi-factor and a lot more secure than just username and password, and these prevent against credential stuffing attacks. Another thing you can do is align your password policies with your app with NIST's 800-63B guidelines. NIST is the National Institute of Standards and Technology. They develop all kinds of standard documents. They're a government organization. They publish a lot of these standards and guidelines. And so if you have an app where users are registering, where you manage passwords and user accounts, you definitely want to take a look at this, and I recommend using what they recommend. Limit or increasingly delay failed login attempts is another thing that you can do to help reduce the possibility of an automated attack. You might write a script or something to do this on your web server, or there might be security settings in your hosting provider where you might be able to specify a delay for failed login attempts, or just an automatic lockout where it blocks somebody's IP address if they say have like 1,000 failed login attempts within a 24-hour period, or something crazy, something to where you know that they are doing something nefarious and you don't want them to have access to your app. It's worth mentioning that you also want to properly store passwords. If they're stored in a database or something, you need to make sure that they're encrypted, and make sure that they're encrypted properly with a good encryption algorithm. And the OWASP authentication cheat sheet goes over all of the best practices for that kind of stuff.